Part A, questions 1. Eliza invested 25,000 in investment scheme for 15 years. The investment rate offer was 5.5% compounded every 4 months for the first 10 years and 7% compounded every 2 months for the rest of the period. Find the future value of the investment. For these questions, we will use compound interest formula. For the first 10 years, we find the interest rate per period by I equal to 0.055 divided by 2. Because the interest is compounded every 4 months, the number of period is n equal to 3 times 10. So the amount of the 10 years is 43,116 ringgit and 3 cents. For the next 5 years, we repeat the same step with the new rate, and the interest rate per period is I equal to 0.07 divided by 6. Because now it is compounded every 2 months, the number of period is n equal to 6 times 5. So the final answer of the future value is 61,060 ringgit and 73 cents.
Years time, Arif want to have enough money to pay 10% down payment on a bungalow that costs 415,000 ringgit. He invests in a saving account that pays an interest of 6.53% compounded semi-annually. So the first Roman, find the amount of the down payment that he need to pay for the property. So the bungalow cost is 450,000 ringgit. So the down payment is 10%, which is 10 divided by 100, and times 415,000 ringgit. So the total amount is 45,000 ringgit. How much should he invest today to have enough money for the down payment? So we use formula S equal to P bracket 1 plus I cos the bracket power by n. So S is 45,000 ringgit equal to P bracket 1 plus 0.0653 divided by 2 close the bracket power by 2 times 10, which is 20. So the total amount is P equal to 23,667 ringgit 34 cents.
Part A, questions number 2A. 7,000 ringgit was invested for 5 years. The bank offered 5% compounded monthly for the first 3 years and R% compounded quarterly for the rest of the period. If the amount in the account was accumulated 9,560 ringgit at the end of the investment period, find R. For these questions, we will use compound interest formula. The investment start with 7,000 ringgit for a total 5 years. For the first 3 years, the bank give 5% interest compounded monthly. So we calculate the amount after 3 years. 7,000 ringgit times 1 plus 0.05 over 12 to the power of 12 times 3 equals 8,130 ringgit and 31 cents. So this means that after 3 years, the money has grown to 8,130 ringgit and 31 cents. Next, for the remaining 2 years, the interest rate changed to R% and it is compounded quarterly, which is 4 times a year. So we continue, 8,130 ringgit and 31 cents times 1 plus R% over 4 to the power of 4 times 2 equals 9,560 ringgit. Then we simplify, 1 plus R% over 4 to the power of 8 equals 9,560 divided by 8,130 ringgit and 31 cents. To find R% equals the 8 root of 9,560 over 8,130 ringgit and 31 cents minus 1 times 4. After calculating, R equal to 8.18%. Paris took a loan of 65,000 ringgit from a bank that charged 4.25% compounded monthly, which is 12 times a year. After some years, the total amount he has to pay becomes 80,360 ringgit, and we want to find the value of T and the interest charge. To find T, we use the compound interest formula. The monthly interest rate is 0.0425 divided by 12. This gives the value 1.0035416667. So the equations becomes 80,360 equals 65,000 times 1.0035416667 to the power of 12 T. We then divide both sides, 1.236307692. To solve for T, we take natural log. In 1.0035416667 to the power 12 T equals in of 1.236307692. Then, after calculating, T equal to 5.00 years. Next, we find amount of interest charge, which is 80,360 minus 65,000, which is the answer is 15,360 ringgit.
Part B, question 1. A. Zikri invested 800 ringgit every 6 months into an investment scheme for 12 years and 6 months that pays an interest rate of 5.4% compounded semi-annually. Find the future value at the end of the investment period. So Zikri invested 800 ringgit. 800 ringgit is a future value. It's a future value every 6 months into an investment scheme for 12 years and 6 months. 12 years and 6 months is time that pays an interest rate of 5.4%. 5.4% is a K, compounded semi-annually, which means N equal to. Find the future value at the end of the investment period. So it's looking for future value. So we use a future value formula, which is S equal to R bracket 1 plus I close the bracket power by N minus 1 divide by I. So 800 ringgit bracket 1 plus 0.054 divided by 2, close the bracket, power by 2 times 12.5 and minus 1, all that divide into 0.054 divide 2. So we get 800, open the bracket, 1 plus 0.027, close the bracket, power by 25, minus 1, and divide 0.027. So the total amount we get is RM 28,045 ringgit 30 cents. Next question B. Alia takes a loan that charge interest 4.4% compounded monthly. She repays the loan in 6 years with a monthly payment of 237 ringgit 42 cents. Immediately after paying the 15th payment, she decides to settle the balance of the loan. Find the balance to be repaid. Okay. Alia takes a loan that charge interest 4.4%. 4.4% is a K. Compounded monthly, which means M equal to 12. She repays the loan in 6 years. It was a time with a monthly payment of 257 ringgit 42 cents. It was a monthly payment. Immediately after paying the 15th payment, she decided to settle the balance of the loan. Find the balance to be repaid. Okay. So charge interest is at 4.4%. M equal to 12. A equal to 6 years. To get mine, 6 times 12 equal to 72. Mine monthly payment is 237 ringgit 42 cents. So 72 minus 15, we get 22. We use a present value formula, which is A equal to R bracket 1 minus bracket 1 plus I, close the bracket, power by negative n, and divide by I. So we just mention it all. 237 ringgit 32 cents. Bracket 1 minus bracket 1 plus 0.044 divide by 12, close the bracket, and power by negative 22, and all that we divide by 0.044 and divide by 12. So the total amount we get 5,009 ringgit 21 cents.
First, we identify the given information. The loan amount is 240,000 ringgit. The monthly payment is 3,146 ringgit and 88 cents. And the annual interest rate is 4.5% per year, compounded monthly. Therefore, the monthly interest rate is 0.00375. Next, we use the formula for the present value of an ordinary annuity. Amount of loan equal monthly payment multiplied by the quantity of 1 minus the quantity 1 plus monthly interest rate raised to the power of negative number of payment, all divided by the monthly interest rate. We then substitute the given values into the formula. So 240,000 ringgit equals 3,146 ringgit and 88 cents multiplied by the quantity of 1 minus the quantity 1 plus 0.00375 raised to the power of negative n, all divided by 0.00375. After simplifying, the multiply the loan amount by the monthly interest rate and divided by the monthly payment. 240,000 multiplied by 0.00375 divided by 3,146 ringgit and 88 cents equal 1 minus the quantity 1.00375 raised to the power of negative n. This gives 0.286, approximately equal 1 minus 1.00375 raised to the power of negative n. Next, we isolate the negative exponent term. 1.00375 raised to the power of negative n equal 1 minus 0.286, which equals 0.714 approximately. To solve for n, we take the natural logarithm on both sides, which is log the natural logarithm of 0.714 equal negative n multiplied by the natural logarithm of 1.00375. Finally, we divided both sides by the negative of the natural logarithm of 1.00375. N equals negative the natural logarithm of 0.714 divided by the natural logarithm of 1.00375, which gives n equal 90 months. First, we identify the given information. The monthly payment is 3,146 ringgit and 88 cents. The annual interest rate is 4.5% per year, compounded monthly, and the monthly interest rate is therefore 0.042032047 divided by 12, which is approximately 0.0035. We use the future value formula of an ordinary annuity. Future value equals the monthly payment multiplied by the quantity of 1 plus the monthly interest rate raised to the power of the number of missed payment minus 1, all divided by the monthly interest rate. We then substitute the known values. Future value equals 3,146 ringgit and 88 cents multiplied by the quantity of 1 plus 0.042032047 divided by 12 raised to the power of 11 minus 1,
all divided by 0.0420320427 divided by 12. After calculating, we get approximately 11.20858781 multiplied by 3,146 ringgit and 88 cent. Finally, multiplying this together give approximately 353,272 ringgit and 8 cent. Therefore, if Nelida failed to pay the first and monthly payment, she should pay 353,272 ringgit and 8 cent on the 11 months to settle all the outstanding arrears.